Started. Welcome to week 2 of COMP2006, Introduction to C++. We're going to do a quick recap from last week, everything that we covered, getting everything set up. There is a quiz that we'll do after the recap. So you can see I'm on the Blackboard Weekly Learning week 2 here. So all I did to get there, if you click your courses and go into Introduction to C++, this is mine here. On the left-hand side, we can go to Weekly Learning, and then you'll see the folders for week 1 and for week 2. Inside of week 2, you'll see there's all of this good information. So if you're doing this week asynchronously, you can go through all of those PowerPoints on your own time and read through them, run through them. There's also a video here. So for you guys that are watching this live right now, I'd also encourage you guys to watch this video. It's a 7-minute video on YouTube for this. This course has a playlist on my YouTube channel that basically covers what we're going to talk about this semester. So if I just open it here and pause it, you can see the list of things here. So I just talked about it, 7 minutes long. We talk about all of these things and a little bit of a rough or really high level view of the curriculum that we're going to talk about. And at the end here, we get into some more advanced stuff. And depending on the speed of the class, if we can get to those, we will cover those. If we can't, we'll spend some more time making sure that everybody understands the basics and the introduction in C++. So take some time, watch this really quickly. And then if you're watching async as well, watch that video right there. Cool. So before we get into the recap quiz, it should be open. Let me know if you guys can see it now, because I had it closed until about 11. So if you guys are on Blackboard, let me know if you guys can see that recap quiz. Before we do that, we're going to take a look at this PowerPoint, the recap PowerPoint, just to refresh kind of what we did from last week. It'd be really helpful if you could upload the syllabus file. Oh, for sure. Yes, I totally forgot to do that. That will be in course information. All right, I will upload that on our next break. When we take like a little 10-minute break, I'll upload that syllabus file so you can take a look at it there. Cool. Awesome. Thanks, Fatima. Okay, Raymond, you see it? Yep. Okay, cool. You see it. Hoorah. Awesome. Okay, cool. So a little bit of a recap. I'm just going to drag this PowerPoint over. This is the recap PowerPoint just to refresh what we talked about last week. Before we jump into that, it's just a little quiz. It's worth like a really tiny fraction of your mark, but it's just to, refresh your brain, make sure that what we learned last week, you're going to remember this week and going forward, and it's just going to solidify that learning that we covered. So we did our intro to the course syllabus and the course outline. Again, I'll upload those. So if you ever want access to those, remember they're on Blackboard. I'll show you right here in the course information section on the left-hand side. So if you just open this, it'll take you to the section that has faculty information here, the course outline, and then I'll put the syllabus right underneath that. I also put that video for the curriculum overview in the same section. So if you can't find it in week 2, it's also in the course information section. So we did that. We talked about expectations and passing grades, late marks, and we also talked about plagiarism. Hopefully this is just ringing some bells. If you guys have any questions about this stuff, no worries, I'll totally answer them. Then we talked about the history of C++. So we talked about how it started in 1970, and then kind of moved from being called C to C++, or C with object-oriented programming elements. And then they added the OOP aspects to it, and then they changed the name, and then we started getting the C++ standard in 2003, and then after 2011, we have modern C++ versus classical C++. That's everything before 2011. So that's kind of the next thing that we covered there, classical C++ versus modern C++, what are the differences, and how the 11 standard and later is modern C++. We also talked about why learn C++. So, and even Fatima was saying it this morning, how popular of a language it is, right? It's still among the top 4 programming languages in 2021. and it's been around for 20 years, so it's consistently popular because salary plus plus, right? I'm glad you remember that from the PowerPoint, Boora. Definitely for the best that they changed the name. Totally, I agree. Um, and then we also learned it's still relevant. So if you go to Stack Overflow or GitHub, you can see that the community is incredibly active with the repositories and the questions that are being asked about the language. It's powerful. So remember, there was 4 reasons. It was, I said them now. Powerful, um, meaning that it's scalable. I can pull up the PowerPoint here just because I want to make sure I actually have the right 4 that I'm going to tell you guys. Introduction to C++. Okay. Why learn it? Popular, I said that. Relevant, I said that. Powerful. And then salary plus plus, which is what Boora said. It's good career opportunities. So these are the main 4 that you want to remember. 1, 2, 3, and 4. Cool? Awesome. Then we talked about, after modern C++ versus classical C++, we talked about the build process. So we talked about what source code is, and then what the compiler does with source code. We talked about what object code is, and how source code gets compiled into object code. Then we talked about what the linker does, which links our object code to other people's object code. So if we're including an external library like the IO stream library for input and output into the console, then it links that object code to our program all into one executable program, usually called main.exe, right? So we talked about that build process. Remember, there was that visual with the arrows. And if you ever want to go back to that, you can see it. So that's the order that things happen. And then we installed our compiler on our machine. So we used the MinGW W64, and then we set the path environment. So remember, we downloaded, we installed. Now I know someone was having problems with getting it installed. If you can't get it working, make sure that it's on the bit version for your computer. So if you're a 64 or a 32-bit, and then just try reinstalling or restarting your computer, and make sure that you're an admin when you run some of the commands if it's not working. So always, turn it off, turn it on again as your first solution. Try Googling some of the problems, and then I know you emailed me. I'm forgetting who it was the second I saw it earlier in the participants panel, but hopefully you get that working, because that would be awesome. So we set the path environment, and then we installed CodeLite, which is our IDE. And then we configured a setting, a template setting that we can start every project from. So we had our base settings for dash static, which kind of just removes some unnecessary warnings. We turned on code completion, and then we also made sure that we were using C++ 17 code hints, right? And then we talked about what the active project model is. What's the active project model? I'm going to ask someone. Feel free to use your mic or type in the chat. I did a lot of talking here about what we covered. So hopefully I want to see if someone remembers what's the active project model in CodeLite in our IDE. I'll give you a hint. So I've got the CodeLite editor open here. I'll just drag it over. All right. So I've got all these projects on the side. If I double click, see how that turns bold? If I double click this, that turns bold, right? What is the active project model? Can someone explain it to me? Nobody? Okay. I see a sad face. Oh, there, Bura. Okay. It is actually when we double click on the project in our IDE, and it makes our main project to be built and compiled. Awesome. Thank you, Bura. Perfect. It took a little bit, and I know you were typing all that, so that's awesome. Okay, so perfect. Yes. So you can have multiple projects in a workspace here, and whichever one is bold and italicized, I can change which one's bold and italicized, by the way, by double clicking or by right clicking and saying make active. So now that that's bold, when I do build and build project, it's going to build the week 1 lab project. If I double click project 1 and then do build project, it's going to build the project 1, as you can see right here, right? Project 1 down in the bottom. Whereas if I double click and do the week 2 lab, then build, it'll now switch to building the week 2 lab, as you can see in the bottom here. Awesome, thanks, Boora. Yep, so that's what the active project model is. And then we did a very quick cover of C++ in the browser. So we can write C++ in the browser. How cool is that? If you're ever in a tight spot and you don't have a laptop or your compiler's not working, so whoever couldn't get it installed, if you want to follow along still and then still try to get it installed later, then you can just write C++ in the browser for the time being, until we get into some more complicated things, but it will work in a pinch, right, if you need it. So that's always an option. Cool. So that's everything we covered. Were there any questions about that stuff, or did everything we cover make sense to everyone? Any questions? Ask now. Why CodeLite? Great question. Simon, can I call you Simon? So I chose CodeLite, and we talked about it a little bit in the past, in last week. So basically, CodeLite is a free IDE, and it's cross-platform. So I didn't know if anyone was using Mac or Windows. It's really lightweight on memory, so I'd also never know. Like I've had students in the past where they have really old laptops and they can't run certain programs. So I wanted to choose something that was light on memory applications so everyone could run it. I wanted to choose something that would work on Mac and Windows, and I wanted something that, what was the other reason? It basically would work for everyone, and it'd be kind of a universal solution. You can use Visual Studio if you want, if you have the memory to run that on your machine and it's a Windows. Unfortunately, C++ doesn't work on Visual Studio on the Mac. You have to use Xcode. There is some plugins, but it's a little bit clunky. And this is just a great platform. It's really minimalist, in terms of like learning C++ and getting into it. It's not like Visual Studio is great, don't get me wrong, but it also can be pretty busy sometimes with all the different settings along the side and the Solution Explorer down the right. And you can kind of feel like things are, out of your control, or you can get a little bit lost in the IDE. But totally, feel free to use whatever you want. You can use VS Code, you can use Visual Studio Community. If you're on a Mac, you can use Xcode, or if you want to use CLion by IntelliJ. Okay, yeah, you use CLion. Perfect. So the CLion is a really awesome IDE, but it's super expensive if you are paying for it. I think you guys, do you get it for free as a student? We were talking about this last week. You get it for free, but only as long as you're a student, right? So as soon as you finish this program, or you have to renew it every year and prove you have a student email every year or something, we can try to do that, but I just want to get everybody set up with a really, solution that kind of covered all angles. And then if you guys feel comfortable, you can kind of expand out from here as we program more and get more comfortable with C++. So cool. Do you know, actually, I'm just curious. I know it's expensive. I don't know the actual price, but what would it be if you did have to pay for it? Maybe you don't know the price, but if you do, that would be 96 bucks a year. Cool. 96 bucks a year. Cool. All right. So that was the recap PowerPoint there. I'll just close that. And let's get into the week 2. So you can find the quiz link here. We're going to do it now. I'm just going to give you guys 10 minutes. I can mute my microphone, but I'll be available. You can ask me questions. You can type in the chat. And I won't necessarily give you the answer, but I will definitely be able to help you out or point you in the right direction for where you want to look. Try not to use Google. Try to do it from your own learning, because it will really solidify, the stuff that we covered and what we learned. Use the PowerPoints from last week. Use the PowerPoints from this week. and just ask me. Oh, it's a smart cross-platform for C, C++, 199 US for the first year per user. Second year, 159. Third year, 119. US though, ooh, that's expensive. That's for the enterprise. Anyways, yeah, if you wanted to do that, you can do that. So cool. So you can find the quiz link here by clicking it, and it will open in a new tab, and then you can hit begin. It has a time limit of 15 minutes. I think it's only like 10 questions, and it's going to be pretty quick. If you guys need more time, which I don't think you will, we're going to complete it in one sitting. So don't open it and then close it. Like if you hit begin right now, then begin. It's due. I just set it for 1 week. So we're going to all do it together today. But for those of you who are doing it asynchronous, just do it before September 20th at midnight, because the test won't be able to be started past that due date. And you're going to be notified when the time expires so that you can submit, right? So you can click the quiz link here, or you can go to assignments and tests right there, and it will be right here, week 1 recap. Okay, so I will just mute my mic. If you have questions, can I get thumbs up if that makes sense to everyone? We're just going to take 10 to 15 minutes and just go through this little recap quiz. Oh, the password. Yes, the password. Okay, there is a password. Just check here. The password is week 1 test. Everything's lowercase. I'll put it in the chat. Week, then the number 1 test. No spaces, all lowercase. All right. And if you're watching this asynchronously and you forget or you want to ask, email me or ask someone in the class. Week 1 test. That's the password to get in. Hit begin. I saw some thumbs ups, so I will just mute, and I will be available here to answer any questions. I'm here to help. So like it is for marks and stuff, but the point of this is so that you guys learn, right? So it's not to penalize you if you don't know. So just ask if you're confused or you don't know where to find something or you want to find the answer for it. I'll give you hints. I'll point you in the right direction. Okay, so just use the resources that you have. Cool. Try not to use Google, because that's going to be the best way for you guys to learn and remember what we did. Cool. I'll just pause the recording here, actually. Awesome. Okay, so that was about 15 minutes. We just did the test. I restarted the recording or unpaused it. So welcome back for those of you who are watching. I also sent out an announcement with an email that has the links to the week 1 recap quiz. If you guys are watching this and you want to find a link to that, and also all the material in the week 2 folder. So the password for that is also in that email if you're looking for the password for the quiz. Cool. Right, let's get into it. So I will share my Blackboard. Here's the announcement, as you can see. And I will go to my week 2 folder. And we are going to get into writing our first program .pptx. Did anyone have any questions about that quiz? It was pretty straightforward, right? Pretty basic stuff. Most of the stuff we just covered in that PowerPoint. If there's any questions I can address, let me know now, and then we can cover them. I liked that one that you asked, Bura, about the --v versus the -- version. So I didn't have that on the recorded because I paused the recording. But basically, one of the questions was, does --v do the same thing as -- version? So I'll just show in command prompt again the best way to test it. So Kennel, you had the same question. So if we do G++, which is our compiler, and then we do --v or version, do we get the same result? So obviously we know -- version from last week because that's how we tested to see if our min.gw compiler was installed correctly. Now, if I just press the up arrow in command prompt, it'll go back to my last command, and I'll just erase those and do the --v, and we'll see here. If it's the same response, then yes, they do the same thing. If it's different, then we know that only one of those commands works. And we can see here there's an error. It's an unrecognized command line did you mean -v, and then there was no input files. So we can also try -v and see if that does something. And we can see that that actually does, that's a different command, right? That has something completely different that might be related to -- version, but in terms of what I was asking on the quiz, -v and -- version are not the same thing. Cool. All right. So if you want to download number 5, the PowerPoint number 5, writing our first program, we're going to get into that right now. You can open up the CodeLite editor, and you can open up the workspace that we created last week. I have a couple extra projects that I've added since then, but you'll have project 1 and you'll have project 2. So a couple things that I wanted to talk about. Slideshow. A couple things I wanted to talk about CodeLite and the IDE before we get into a little bit more detailed programming was a couple more options that we have, just so you guys are aware of them in this IDE. You might be aware of them in other IDEs, but just with CodeLite specifically. So I'm just going to move the chat over there. So remember this workspace view. We can have multiple projects in it. And as you're opening your workspace, you'll see your project 1 and project 2. And remember, we can add projects and switch between our active projects. Now, I already talked about CodeLite here. If I open up my main CPP, we have our line numbers down the side. Okay. And we can change all of that in the settings, preferences. That opens. It's giving me a little bit of a hard time here. But you can change all of the line numbers and settings preferences, and then come down to editor here, and then show line numbers should be one of these options. Where is it? You can change your indentation settings, but where is my line numbers? Some people don't like line numbers. Enable relative line numbers, show line numbers margin, so you can turn them off here, I believe. Cool, in the guide section. I'm going to cancel that. I think it's really helpful to have your line numbers on, and it just helps when I'm referring to code. I'll say line number 4 and 5 where we're changing it. Cool. I think we talked about this code folding, right? With your functions, we talked about how that's helpful when you have a lot of code. You can just close up the functions you're not working on. We talked about the color coding because of the keywords, and then the output pane. So what I want to talk about here, this is where all our compiler messages are displayed and the status of the build. Search and replace is really handy if we want to change a variable name later on and replace the name of something. Now you'll notice there's some other tabs in here like references that we might not use all the time. So what I can do, let's see here, make this my active project. I can actually hide the ones that I don't want to see, right? So build and output are going to be our main ones. But if, say, you accidentally hide it by right-clicking and then clicking the hide button, and you're like, oh, crap, I want that back. How do I get it back? If you just come over to the right-hand side of your output window, I'm just going to stretch this up a little bit so you can see it more easily. If you click this little downwards triangle, you can see a section for hidden tabs, and then you can re-enable by clicking output here. That will put the output box back where it was, where I just clicked it. So if I click that, we can see it reappears here. So we can see there's a couple other hidden tabs that we won't really be using, but there's a Git tab for version control. So if you do want to use that through CodeLite, you can. There's a references, tasks, and SFTP log for secure file transfer protocol. So we won't be using those, but you can enable them through that. Cool. So I just wanted to make you guys aware of that. Now, there's also up in the workspace view here some tabs. So if I just expand this out and make that a little bigger, we can see we have workspace, we have Explorer, and we have tabs. Now, Explorer, you guys might not see this. If I just do close, yours probably looks like this, drag and drop a folder here, okay? Now, basically what this does is it's basically like a Windows Explorer, and it will show a couple more files than what we'll see in our workspace view. So if I actually browse to open a folder here, and I go to my workspace folder, so my test workspace, if I go up, this is my workspace that I'm in, my test workspace right now. These are all my projects, project 1, project 2, week 1 lab, week 2 lab, and week 2 lab complete. If I select this folder and expand it, we'll see there's all my projects that are the same as my workspace. Now, what's different here, let's say in project 1, if I make that my active project, I'm just gonna, don't worry about that. So what's cool here is, actually, we're going to talk about this in a second. So you can add these. I'm going to come back to this in just a second, but I want to talk about these tabs one more time. So we have 3 tabs, right? Now there's more hidden tabs. Same thing in this little bottom right triangle. And then we can actually enable tab groups, outline, and SFTP. We'll just leave those disabled for now. So we have these 3 main tabs: Windows, Explorer, and tabs. And we'll come back to this Explorer one in a section. So I just added my workspace folder, right? Cool. One other thing that you can do is if you don't like the layout here, all right, you can actually drag these around. So if I just click my workspace bar at the top here, right beside where it says workspace view, if I click and hold and drag it around, you can see as I hover it, there's a highlighted blue section. So if I want it on the right-hand side here, I can do that. And it looks a little bit more like Visual Studio, right? If you like having all your code on the left. If you want to have your output window also stacked on the right, we can do that. And then, you know, we have all of this real estate for our programming. Now, if you wanted to save that layout, okay, we can see here in perspective at the top, I can do save current layout as, and then I would just can give it a new name. So instead of default layout, we can call it my name, ben.layout, right? Now you can have, say, a layout for debugging that has specific tools for debugging that are more readily available. And then you can have your programming layout and you can have your testing layout or whatever. And I can now switch between my default layout, which was this, right? And then my Ben layout, which is this, which is kind of cool. So just something to be aware of that you can drag those around. I will keep the default layout for now, just because it's what I'm used to. All right. Now we can use the view options to show or hide certain panes. So up here at the top, say you accidentally close your workspace view and you're like, oh no, and you close your output view and you just have this and you're like, where did my project go? Where are my files? How do I get back to that? If you go to the view tab at the top, you can show and hide certain panels. So here's my output pane and here's my workspace pane. So those are disappeared. We see there's no check mark beside them. So if I click this, my output pane comes back and you can see there's a check mark beside it now. And if I click the workspace pane, same thing, my workspace pane is back. Cool. There's also a toolbar in here, which some of you might like. So I want to show you this. You can show toolbar. Mine is unchecked because I think it looks a little cluttery. But if you do like it, it might remind you a little bit more of something you'd see in NetBeans or whatever, where you've got those buttons at the top. So if you want to run your active project, I can click this run, this little icon of a running man. If you want to debug or start the debugger or stop the project, all of those are in there. You're going to clean the project or rebuild it. You can click those buttons. I'm going to do it all through the menu so that you can see exactly what I'm clicking. But if you want to do it through the toolbar, all power to you. Okay, cool. So you can totally customize your layout the way you want it. Awesome. One other thing I wanted to talk about. All right. We're going to do this first. We are going to create a new project in our workspace and erase the source code and then type the following code. All right. So I will actually open CodeLite and show you guys this. You can follow along. So I'm in my workspace tab. Any questions about everything I've covered so far? It's just basic IDE stuff. We're going to right click my workspace, new project. and we can call it first program. Remember, no spaces here. And then we're going to use user templates and that CPP template we created last week. The compiler should be the MinGW. On Windows, it's GNU. On Mac, it's LLDB, debugger, and the build system will be default. All right, so make sure these are your settings in our new project. I'm going to call it first program, and then I'm going to click OK. All right. So once I click OK, my project's here on the left. I'm going to double click it to make sure it's the active program, and then I'm going to open up the main.cpp and make sure it's my only file open. And I'll actually just erase everything inside of my main function. All right. So we've got our include IO stream and then int main. Now it does have to return 0, so we will return 0 at the very end, a couple lines in front to do our actual program. Okay. So I want to make sure when I right click this, my my workspace, in workspace settings, there's a tab called code completion. It should be turned on for you, but enable C++ 17 standard code completion. So what that means and how we can use that. So at the top here where I have include IO stream, if I start typing IOS, okay, wait, I may have to delete the rest of this. If I start typing IOS T, you saw it pop up there for a second. There we go. We can see some of these code completions. It's trying to guess what I want to write. All right. So I want to include IOS T IO stream. Should come up. It's not coming up. Did you guys get the code completion working on yours? Just let me know. Mine just gave me a little bit of a tough time there, but.
I'm sorry, Professor. Could you repeat, please? When I open new project, in category, I have to choose user template. In type, I have just Cobra. It doesn't have C++.
Okay, so you might not have created the template last week when we saved the template, or you're in a different workspace than where your template's stored. Did you open up the same template or the same workspace as last week?
I didn't create template. Okay, I will look last video. Thank you.
Okay, no worries. Yeah, so you can find the video on how to create the template in last week's, but also you can just make sure that you erase the source code inside of your new program, and then the settings you want, if you guys don't know what the template settings were, remember when we right click and go to project settings, in the compiler section, we wanted to make sure that we turned on, if I scroll down, this fifth one down, C++ 17 features, so that we're using modern C++. And then in the linker, you want -static. And this is a Windows only feature. So don't type that if you're on Mac. All right, those are the main things. And then the code completion, obviously, that we just looked at. Okay, so if I start typing int, you can see the code completion kind of coming up. I'm just going to type int main return 0 because it has to return 0, and then we close our bracket. All right, so we're going to write our first program here. This is going to be asking the user for their favorite number. So we're going to want to store the favorite number somewhere. How do we want to store that? Any ideas? How do we store information while programming? Variables. Awesome. Thanks, Bura. Yes, variables. So we want to make a variable. And if we're going to store in a number, what type of variable do you think we want to store? Int. Great. Thanks, Simon. So we want an int. And yes, an integer. Perfect. And we're just going to, you can call it whatever you want. Favorite number. I keep them all lowercase and I put underscores in between where the spaces would be. All right. So we want to store it in an int. called favorite number. Now, we did a little bit of this last week with std : cout, which is going to write to the console. Now, cout writes out to the console, and cin reads from the console. All right, and then we're going to do the two open angle brackets. This is the insertion operator. If I had them facing the other way, okay, for example, this, that's the extraction operator. Okay, so the insertion operator, we want to insert into the console. All right, and then we're going to do a string inside of these two quotes. Enter your favorite number between 1 and 100. All right, and I'm just going to do colon, a space, and that line. Now, how do we store whatever they enter into that variable we created? Any ideas? std::cin, perfect. Thanks, Bura. You're on it. Okay, so std : cin, and then the extraction operator. And we want to save it into that variable we just created. And as I start typing, this is the code completion, all right? I start typing favorite number. I can just hit tab, and then the code completes, and I can just put my semicolon and end that line. Awesome. So that's going to cin from the console whatever they enter after this statement into this variable. Now you can see I don't have any of the keywords like std or cin working. And you can see this whole line is red. If I do Control S here, which will save the project, we'll see that line turn green, and then I should be getting those highlighted words. I save it, and then there we go. We can see. So if you ever wonder why you don't have some of the keywords with the right color coding, again, even like double clicking this and I can see where it's defined or where it's used, make sure you have your project saved. Okay, so we're going to save it in our favorite number. Okay, so that's what we want to do. We want to grab whatever the user says and store it somewhere using a variable. Now, we have to tell the compiler what type of variable this is, right? So we chose an int, because remember, the compiler is going to be really dumb. So it's just going to do whatever. It doesn't know what type of information we're asking for. It doesn't know that we're asking for a number. So we have to tell it that we're expecting a number. All right? Just like when you're baking a cake and you want to crack the eggs, you have to tell it to crack the eggs before putting the eggs in the bowl. So we can now read information into this variable. And then now what we want to do is just say, amazing, that's my favorite number 2. So we're just going to go std cout, insertion operator into the console. Amazing. It's my favorite number 2. Close your string, and then we will append an end line, and there's my code completion. End line there. I don't want the open parentheses though. Cool. End line, and then return 0. Okay. So I can save that. Awesome. So remember, all C++ programs must have a main function. That's this, main, everything inside this bracket. So when I click that top one, you can see it highlights where the ending bracket is. And if I click the bottom one, same thing, it highlights where the beginning bracket is. So everything inside of this is my main function. And all C++ programs can only have one main function. So now we want to build this program. How do we build the program? Anybody? There's multiple ways to do it. If you have the toolbar, you can. If you have F5, let's see if F5, build project. I have F7 for mine. Build and run, Control F5 is for me. Build section at the top, build and run. Okay, so you can do build and run project. We can also just compile it before we actually run it. Another option is to right click in the workspace here, all right, and do it from here. So you can do clean, rebuild, build, and compile. So I'm just going to do a build project, which will just compile it. And we'll see at the bottom here, make sure you're on this program, first program, and it's double clicked because of the active project model. We can see 0 errors, 0 warnings in the bottom right there, okay? Which means it compiled correctly. Everything got put into object code, and we can see that. I'm just going to use the annotation tool here. Remember, .o is object code. So right here, I don't know if you guys can see this. It's main.cpp.o. So it compiled main.cpp into main.cpp.o. All right, so that's what an object code is. And we can see 0 errors, 0 warnings down here. Okay, so before we run the project, I want to talk a little bit about building, cleaning, and rebuilding. So basically, building, what we just did, is going to compile and link together with those external libraries. So compiles it into the object code, and then it links to the external libraries like IOStream. Okay, there's several steps, and the first is the compiling, which converts that source code to object format or machine language or binary, and creates that obj file or that .o file, which I just highlighted with my annotation tool. Now, the clean process will actually remove those object files, okay? And it puts it back into a clean state. So whenever you see up here, build and clean, you might wonder, like, what does that actually do? What is it cleaning? It's removing the object files that were created from the source code. So basically, if we come back here, when you tell the compiler to build, it's only going to build what needs to be built. So if you have multiple files, we only are working with one right now. We only have main.cpp. But if we had, say, file 1.cpp and file 2.cpp, and we already built file 1.cpp and it has the file 1.cpp.obj, that object code, because it's already been built and compiled, when we build the project again, it's going to look and say, hey, I already have the file 1 code built. I'm not going to bother wasting any energy processing that. So I'm only going to build the file 2 object. Okay? So it's only going to build what needs to be built. If it has that file of source code already in an object file, it's going to say, why bother building it if I already have it? So it won't rebuild it. Okay? So what cleaning does is cleaning actually removes those object files, puts it into a clean state so nothing is built. So the compiler looks at it and says, I need to build everything. All right, so occasionally you're going to want to clean and then build again so that you have a clean build. It's more relevant with bigger projects. So if you have like many files, then it's more often that it's going to happen then than just with one file. Okay, so build only is going to build what needs to be built. Rebuild, okay, when you look at the project here and we come up and say build rebuild project down there, is a combination of clean and build. So it's basically like if I click clean project and then after I come back and I click build, okay, those two steps are basically what rebuild is doing. Rebuild does clean and then build. Okay, so build and then run and then build and execute will build the project and then actually run the project. Okay. So I'm going to show you a bit of an example about what I'm talking about. So remember I showed you the Explorer tab here. I'm going to expand this. This Explorer tab, if I expand, if I just refresh this, we can see my first program is in there, okay? If I expand my first program, we can see there's a main.cpp, first program.txt, compile flags.txt, a .mk, and a .project file. Okay, but there's no .o files in here. Now, if I come back and I right-click my first program and I build it, and we can see, all right, 0 errors, 0 warnings. Come back to the Explorer tab, and we refresh. I come to my first program. We should be able to see there's a debug folder here now. This debug folder wasn't here before, and inside the debug folder, I have a main.cpp.o and a main.cpp.o.d. Now, the reason it's in a debug folder is when I'm in my workspace, we can see that under this arrow, it says first program : debug. I can also work under a release perspective, but for our purposes, we'll always be in the debug. It just allows you to have different tools, and it builds like a debug log when you're actually building it. So if there are errors, you can look at the log. When you're doing a release version, it's when you're completely finished your project and you want to do a really clean, minimalistic build, and there's no extra kind of debug junk or log information in the build. All right. So I'm in my debug perspective, and then you can see that debug folder has all of this object code. Now, if I clean this project, okay, that's what I was talking about. If I clean it, that's going to remove all of those .o or object or obj files, okay? So if I refresh my Explorer view, I'm coming back to my Explorer tab and I refresh. When I expand my first program, we can see there's that debug folder's gone. All those obj files are gone. And so when I do build or build and run, it's going to create that folder again, okay? Awesome. Any questions about that? That's just a really practical example of what building, cleaning, or rebuilding does. And it's the same in all IDEs, right? It's the same with all compilers and those kinds of things. So if you do that in Java and you were ever confused, hopefully that was a good recap. So now what I can do is I can just build and run the project. And I'm going to get my command prompt here. For some reason, my my antivirus. There we go. Here's my project. Enter your favorite number between 1 and 100. Zoom into this because it's probably a little small on your screen. Enter your favorite number between 1 and 100. I'll enter 12. Hit enter. Amazing. That's my favorite number too. That's exactly what we were expecting. Okay. So it works. I hit that, program exited. Cool. Awesome. So hopefully that covered a little bit about variables, input, output with C out and C in, storing an int, and then talking about build, rebuild, and clean. You can exit that PowerPoint. So that PowerPoint was PowerPoint number 5 on Blackboard. We're going to take a quick little break here. Does anybody have any questions? Did everybody get that working right?
Yes, Professor, because I never used cleaning project before, so that's important step. Can I just build and run project, or I have to clean project sometime?
So the cleaning of a project is more relevant when you have multiple files or bigger projects. So right now you can just build and execute or build and run every time. But once you start getting into really big projects that have multiple files, there might be some instances where you need to remove those OBJ files and rebuild everything just to clear it from the memory or clear it from the cache so that everything is kind of clean. And if there's some weird bugs that are going on, so that'll be more relevant down the line when we create bigger projects. But for now, you can just build and run.
Okay, thank you. But it's good practice if I have to start to clean my project, yes?
Yeah, you don't have to do it every time. Like I would say, only try it when there's like a bug and your program's maybe not working. Then I would give it a shot because it could maybe potentially be an issue that would be resolved that way. But for the most part, you should just be able to just build and run. Cool. Awesome. We're going to take a quick 10-minute break. We'll be back at 12:20. I'll pause the recording, and then we're going to get into talking about errors, compiler warnings, linker errors, and all that good stuff, okay? So we'll be back in 10 minutes. Go get a coffee, take a break, stretch your legs, and we'll be back in just a minute. Thanks, guys. Hi, guys. Welcome back. The recording is started again, and you should be able to hear and see me. Just let me know in chat if that is correct. Okay. So hopefully we've had a chance to stretch our legs. Awesome. Cool. Thank you for the thumbs up. Mila, cool. Awesome. I see you added some a profile picture. That's great. I really appreciate it. That helps me remember a lot easier. Cool. Okay. So let's get started with our next little slide here, compiler errors. Okay. So you can find it in Blackboard in the week 2 learning, in the weekly learning. I know what you're thinking, okay? So, sheesh, we haven't barely started programming in C++, and he's already talking about errors. He's already talking about things going wrong. Don't get discouraged. Don't get worried. This is actually going to be more helpful if we cover it right away, so you know what to expect if something goes wrong, and you don't freak out or think, "Oh crap, what's happening? What is this? Why is the error message yelling at me and saying I did something wrong?" I think it's more beneficial if we cover this right away so that you can kind of, be calm and see that error message and know how to read it and how to go to the problem area and fix it, okay? I'll show you some common errors that people come across, and then I'm going to talk about the different types of errors that there are, okay? So coming to the compiler errors, number 6 PowerPoint, I'm just going to share that slideshow with you guys now, and we're going to talk about it a bit, and I'll give you some examples in CodeLite C++ IDE. Okay. You guys should be able to see that, I think. Let me know. Just said I had some network problems there, so hopefully that is coming through. Awesome. Okay, cool. Start the slideshow. Cool. So compiler errors. This is going to be the first type of error that we're talking about today, okay? So the chat over. Sorry guys, 1 second. And then make sure I can go here. Awesome. All right. So I'm just going to use this hello world. It's a little bit easier as the example with some of the compiler errors in my project 1, okay? Yes, I was going to talk about that, Simon. Yep, don't worry about that. That is coming up, okay? That's a cool little shortcut that we can do. And I will talk about that in a second. Okay, so with compiler errors, okay. So basically, programming languages have rules. We talked about how there are very specific rules, and these rules are called syntax, okay? Those rules are so the compiler can translate that code to machine code, and each specific rule must be followed. So one specific rule, for example, is that all lines have to end in a semicolon, okay? Or quotes have to have, a string has to have a quote on the beginning and on the end. So we can see here in the first example that the word errors is missing its closing quote mark. And we can see on the second line there, the return 0 statement is missing the closing semicolon. Okay, so those are called syntax errors in the compiler. Okay, now the next type of error that's a compiler error is semantic errors. So it's something is wrong with the meaning of the code. So it's not necessarily like you didn't follow a rule, but it's when it doesn't make sense. So like A plus B, okay, let's think about it. What if A is a string or a person's name and B is a number? So you tried to do my name, Ben, plus 37. It's not going to understand what you want to do, and it's going to have a problem and throw a hissy fit, and it's going to throw an error. Okay, so let's go to our CodeLite here, and let's just do a missing closing quote and see what we get in the errors. Okay, so I have a hello world, and I'm just going to delete that there. I'm going to save it. We can already tell because of the green that the quote is missing, but if I just do a build project, okay, there's our first error. I'm going to expand that a little bit, and we can see we've got multiple errors. So if we just click this first one, we can see the line, that arrow is pointing to this line. It says error missing terminating quote character, okay, at hello world. So it shows you that I have the beginning quote there, but it's missing the terminating one, which means the ending one. All right. And then here, the second error is expected primary expression before return. So somewhere before return, it's expecting another expression, but it doesn't know where that expression is because it thinks this whole thing's a quote. All right. So that's our very first error. Now, we can, what was I going to say? You can fix this obviously easily by adding that quote back. And then if I hit F7, it should be F7. Yeah, F7. To build the project, we can see it builds 0 errors and 0 warnings. Cool. The next common error that I see a lot is end line spelt incorrectly with two L's. Okay, so ENDL colon, but if you have two L's in there, and if you have tired eyes and you've been programming for a couple hours, you're not going to see that. So I save that and build the project. We're going to get an error that basically says end LL is not a member of STD. Now, STD is something that Simon was talking about there. It's a namespace. It's a namespace that we use for cout. So we can actually do a cool little trick here so that we don't have to type STD : every time. We can say that we're using that namespace, and then we can just type cout without this prefix to it. Okay, so it's saying end line, end LL is not a member of STD. Now that's obviously because we spelt that with two L's. Cool. Missing semicolon. So if you're missing a semicolon in your code somewhere, and then you try to build it, you're going to get an error that says something like expected, and then in the single apostrophe here, it says expected semicolon before return. So here's our return statement. So it's expecting, we know somewhere, whatever line's coming before this return, that there's a missing semicolon. All right. We can also see here, cout hello world std end line. It's saying that's where the semicolon should be, on this line. All right. Cool. Now here's an example of a semantic error. Okay. So we have our main function, okay, and it's expecting a return of an int. So usually we do return 0. Now instead of 0, if we return the word Joe as a string, it's going to say invalid conversion from const char to int, because it's going to try to convert whatever this is, a char or a string, to an int, because that's what it's expecting to be returned from this function. All right, so I don't have to type that in here, but I might as well. We just do a string in here, save it and run. We're going to get that error, invalid conversion from const char to int, because this should be an integer. Okay, cool. Now one last error, missing the beginning. I spelled beginning wrong here. Missing the beginning open curly brace. All right, so if we're missing the open beginning curly brace of our main function, it's going to actually throw multiple errors. But usually, and this is a little trick for you in C++, if you have multiple errors, usually fixing the first error will actually solve all your errors. So I'll show you here. Okay, if I save this and run it, it should be clean, because I fixed that return Joe. And if I just get rid of my beginning curly brace there and run it, build, run, we can see I get 3 errors. So first error is expected initializer before std. So here's std, and it's expecting something called an initializer, all right, which is that open curly brace. Now the next error is expected unqualified ID before return. Okay, so it's like, what's happening here? Where's my opening of my main? And then here, expected declaration before the closing curly brace token. And if you just put a curly brace in there and build it, it will actually get rid of all 3 of those errors, and they're all taken care of. Cool. So fixing that one error will fix many errors. Awesome. Any questions about that? That's all in that PowerPoint right here. Just some little helpful tips. Cool. So, okay, they're using namespace. You want to see that? So if we type this at the beginning, here's another little, we type in using, and here's my using namespace identifier. I hit tab, those are keywords, and then I do std with a semicolon. I no longer have to use std : I can just do cout. All right, and if I build my project, 0 errors, 0 warnings. If I build and run my project, let's bring my, is there any reason you wouldn't want to use the namespace? No, just at the beginning, just so you understand like what's happening, I'm showing you, but yeah, you would use it and then it saves you time, right? Just like including the IO stream, so you don't have to type that input output code. This will save you time by using that namespace. Now, sometimes you'll use multiple namespaces and then you could run into some problems there later, but we don't have to worry about that right now. So there, and it works as expected. So cool. We can just type Z out or C in, right, with our insert or extraction operator, and you don't need that STD : anymore. Cool. All right, now we're going to talk about compiler warnings. So we talked about errors. Now we need to talk about warnings. So basically, a warning is not an error, but you should treat it like an error because it could turn into something later on. So do not ignore a compiler warning, okay? The compiler has recognized an issue with your code that could lead to a potential problem in the future, and it's only a warning right now because the compiler is still able to generate the correct machine code in the background when it does the compiling. So here's an example of a warning. You have an integer called miles driven, so the amount of miles you've driven, and then you do std cout miles driven, okay? The warning you're going to get is miles_driven is used uninitialized, okay? So what that's going to look like here on the next screen, actually, I'll show you an example of it. If I go to CodeLite and say we do that, so we declare an int called miles driven, okay? And then we do cout, and instead of the string, we do miles driven. Just forget the n. Okay, and I save it, and I build. You should get a warning. And the warnings come in yellow, and you can see at the end here, okay, if I annotate this, 0 errors, but 1 warning. And that warning is this right here. Miles driven is used uninitialized in this function. What that means is basically you are using it, you're putting it out to the screen, but it doesn't know what that number is. It's like, okay, you've said that there's a variable, but I have no value for it. You've never set it to be 100 or 0 or anything like that. Okay, so if we actually run this, okay, just get rid of that. We actually run this program, build and run project. Now it says 0 errors, 0 warnings, but I just get 0 as my number. It just defaults to that, okay? So just something to keep in mind. Treat it like an error and try to have a no warnings policy in your code, right? Because it could lead to worse issues in the future. Okay. Here's another example of the same kind of thing with favorite number, int favorite number, and then you do a cout favorite number. It's just going to default to 0, and it's going to say it's used, but it's uninitialized, okay? Now, in this example, okay, we have our int favorite number, and we set it to 100, okay? But then we never actually put it out to the console. So it's saying you have a variable called favorite number. It's set, but it's not used. So it's thinking like, why declare a variable if you're not going to use it? Why create space in my memory that I have to remember this number 100 if you're never going to actually use it in your program and you're just doing cout hello, right? So another example of something that you want to try to avoid doing. Cool. So those are compiler warnings. All right, does that help? Are we covering things that are, a little bit useful for people? Just in case you come across this in your labs or some of your assignments, you're going to know how to deal with them, all right? Cool. So linker errors. Remember, we have our compiler errors, which compiles it into machine code. And then we have our linker error, which is where it grabs those third-party libraries and puts everything together into one complete main executable file. A linker error is basically when you're having trouble linking all those object files, those .obj or .o files together to create that executable. So usually there's a library out there that's missing somewhere, or you referred to it, but you typed the name wrong. So basically here, just full screen this, you can have a clean compile, right? So here's my code. I am including IOStream, which is a third-party library, and then I'm saying there's an external integer named x, okay? So I'm saying there's a variable declared somewhere outside of this program called x, and then later in my main program, I'm doing a cout to the console hello world, and then on a new line, I'm doing a cout with that variable x, that external variable. And then I'm just doing my return code of 0. Now, it says there's 0 errors and 0 warnings down here, right? We can see, cool, I can use the pen here. Down here, 0 errors and 0 warnings, so I'm not going to know that there's anything wrong. But the problem is this, I'm saying exists somewhere, it doesn't. So it's going to look down here at this error, and it's going to say there's an undefined reference to X. It doesn't know where to look. This is a classic linker error, okay? And we can tell it's a linker error. Where does it say it? LD, right there, returned 1. So you know how we always wanted to return 0? We can see here it returned 1, which means there was an error. And then here, it's saying the error is LD returned, which is your linker, okay? So it returned 1 as its exit status, okay? Now, the main.cpp file, which is the only file in this project right here. Oh, I just drew over it. The main.cpp file is going to be compiled to that main.o or main.object, and there's a reference to X. The linker needs to grab those libraries from iostream and also combine them to the main.o and iostream.o to create the main.exe, okay? So we know that the iostream library exists out there, and basically what I've told the compiler here is that that X variable is defined by someone else and not me. It's not in this program, it's somewhere else. Obviously, it's not defined by somewhere else because we just forced this error and we put that in there, and it's wanting to print X, but it doesn't know where X is. It doesn't know what the value is. So the linker is saying, what's going on here? I don't know where to grab this. So basically, it's grabbing your main.o file, your iostream, and it's putting it all together in your main.exe, but it's saying, like, where's this X coming from? It's looking somewhere else, but it doesn't know where to look, okay? This error is an undefined reference to X. Linker errors are actually kind of tricky to fix. So oftentimes those files are missing. And often if you're using third-party libraries a lot more, then this will happen to you a lot more. If you're not using third-party libraries, then you won't really come into this that often. Okay, so that's a linker errors. Do I want to keep? Nope. So I'll close those. And runtime errors. We want to talk about runtime errors. Do you guys know what a runtime error is? Can anyone tell me before I get into this? What's a runtime error? CERR? Can you expand a little bit on CERR? Simon?
Well, it's an error that you create in some case. For example, if you choose number from 1 to 100 and user input 200, it will be like an error and it will be printed in console.
Yep, totally. Perfect. Yep, thank you. That's great. And Raymond said it too there. Something breaks while the program's running. Yeah, it's exactly what it sounds like. A runtime error is what occurs while the program is executing. That's exactly what you said, Raymond. Another typical example, Simon, of some runtime errors are like if you do a divide by 0, or if you're looking for an external file and you're trying to do a file read, and the file's not found, or say you run out of memory because the program has like a memory leak or something like that, then the program's basically going to crash. So it can cause your program to crash. And what we can do with this, so like your example with the pick a number between 0 and 100, we can have exception handling. So we can say like if that number is greater than 100, then give feedback to the user saying like, hey, your number is too big. Right now on our program, enter your favorite number. So if I come here, there won't actually be an error thrown. If I go to my first program, where I'm asking enter your favorite number between 1 and 100, I can actually run this and put in a number greater than 100, and the program won't really care. So I'll show you an example right now on command prompt. Let's see. Running, I did a build and run. Build and execute. There it is. So I'll just zoom in so you guys can see it. Enter your number between 1 and 100. So you said, for example, if I put in 200, there'd be a runtime error, but actually I don't have any input validation here. So all I'm going to do is I'm going to take what was input and I'm going to store that in the favorite number. Now, if I type something like a string, because it's expecting an int, that'll probably throw an error. But if I type in the number 2000 and hit enter, it's not going to have a problem with that. It'll just print out amazing. That's my favorite number too. And favorite number right now will actually have the value 2000. So later on, you can do an if statement and try to catch that error that's happening. But it's more like something like if I did like a divide by 0 or something like that. Does that make sense? Cool. The last error I want to talk to you guys about is logic errors. These are basically errors that, well, actually, I'm going to ask you guys, what is a logic error? I feel like I do a lot of talking, so I want to try to get you guys involved. What is a logic error?
Yeah.
Oh, I heard something.
It's like something to do with like the relational operators. Like you're asking for a number smaller than 0 and bigger than 5. So I guess that would be a logic error.
So if you're asking for a number smaller than 0 and bigger than 5, and that doesn't really make sense because how can something be smaller than 0 but also bigger than 5? Is that what you're saying?
Yes.
Right, totally. Yeah, that's a great example. Jillian said, isn't that like storing a double in an int? So a double is also a way to store a number. So basically a double just has like a floating decimal points. So there probably won't be an error thrown. You might get a warning. Bura says, maybe trying to multiply a string with a number. Yeah, so that could also be we talked about that. That's more of a semantic error, like a compiler error. So your program actually won't run because of that. With a logic error, your program might still run. It can cause it to crash. It can cause it to run incorrectly, but your program also might still run, but you might not get the output you're expecting. So I'll show you an example on the next screen. But that's more of a semantic error, Bura, when you're trying to multiply like two different variable types, like a string and a number. Kennel said it runs the program, but not in the correct way. Yes. Okay. So Simon, the divide by 0, that's more of what we just talked about. That's a runtime error. So if you do divide by 0 in your program, it'll just crash. And so as you're running, your program will crash, and that's a runtime error because it happened while the program is running. Now, logic error, just like what Kennel said, I really liked your example or your description. It runs, but not in the correct way. So if I just go to the next slide here, it's an error or bug in your code that can cause your program to run incorrectly. So it's a logic error. It's basically a mistake made by the programmer. So like logic, if you think about logic, it's like in your head, right? It's like how you think, and say you just thought something the wrong way. So let's suppose we have a program that determines if a person can vote or not in an election. So we have an election coming up in Canada, and you need to be 18 years or older to vote. Now, what is the logic error with the code that I have here in the PowerPoint? You have to be 18 years or older to vote. What's the logic error? So the code will run, right? There's not going to be any compiler error. Everything will run. It won't crash. There's no runtime error. Hoorah, perfect. Yes. So 18 is not accepted here. So basically it's saying if you're greater than 18, right? I have an if statement. I know we haven't covered if statements yet, but they're basically the same as in Java. If your age is greater than 18, then you can vote, which means 19, right? Yes, exactly. Fatima's got it. So you need greater than or equals, because in this situation, the 18-year-olds could not vote. You could also do another option. There's always multiple options in programming. You could also do age greater than 17, because the next number is 18, right? So perfect. Simon had it right there. Cool. So always test your code and make sure that it's working the way you expect, because these mistakes can be kind of sometimes careless, or we have incomplete or missing information, or sometimes you have multiple developers on it and you won't catch that there's a logic error. Okay, so that is all the types of errors. All of those PowerPoints, okay, are in the Blackboard right here. We have linker errors, runtime errors, logic errors. If you want to go through those PowerPoints, you can download them right here from slides 4 to 10, okay? There's also a PowerPoint here on how to write your first C++ program. Some of these are really helpful slides. I'll probably go through them next week, cover them a bit this week too. We won't go through them all though. All right, actually, right now. So this is from the textbook that I recommended in the syllabus. Oh, sorry, Fatima, I forgot to post the syllabus in the first break. I will do that in the next break or right after the class is over, okay? So for the slides, this is from the Mirach textbook, these slides. I'm not going to go through them all, but there's some that I found pretty helpful that might be good for you guys, okay? So they start off with the objectives that you're going to learn in the slide section. So if you want to take your time to read through what these are defining, that'll be what you learn if you go through all of this. Now commenting in C++, you can do / for a single line comment, as you can see here. And then if you want to do a block comment, it's the same. It's / with a asterisk. And then every new line you do an asterisk. So in CodeLite, I want to do a comment right before here. This is a favorite. Whoops. This is a variable. Now, if I wanted to do a multi-line comment, I could do this. As I hit enter, it adds those asterisks, multi-line comment, and then you have to do asterisks that to end it. All right. So those are your two types of comments in C++. Cool. So you guys know what parameters are. Parameters are when you pass something to a function. So if we have our main function, you can pass two parameters. Here we're passing an int and a char. All right. And we're expecting a return of an int. Okay. You can also pass no parameters with an empty parentheses. And then you can also do it with the brace. They're just saying you can do the brace up here on the same line as main instead of doing it on the new line. Cool. Skip over some of these. For C++ 11 or later, so for modern C++, you can use exit_success as the value instead of 0. Just an interesting fact. We'll skip these. These are all your keywords in C++. If you're curious to ever know what keywords you can use and what words you can't. And there's more keywords here. Additional keywords here. The two built-in data types for working with numbers. So I know you were talking about it earlier, Jillian, int and double right there, okay? Those are how we can store the two built-in data types for working with numbers. How to define and initialize a variable. We already talked about that today. So you do int and then you do the name. So that's the definition of the variable. And then when you assign it to a number or value, then that's the assignment of that variable, okay? You can also do it all in one statement. So you can define and initialize the variable. Int counter equals 1 is defining it and initializing the integer. Let's see. Naming recommendations. Variables should normally be nouns. I think you guys know that. Using lowercase letters and separating the words with underscores. Using meaningful names that are easy to remember, okay? There's your arithmetic operators. What else did I want to cover? Here's how you include header files to make them more easily accessible. And here's that using namespace example of the code there as well. Let's see. There are some slides that I wanted to cover and some of them that I didn't. Okay, how to send text and a number to the console. Okay, so if you want to do cout, then you use the insertion operator to the console. 4 times 4 is, and then you don't do the end line. You can just do cout again after that semicolon, and then your variable for the actual number, and it will just put it all together on one line. 4 times 4 is 16. Another way to send the same data so you can actually append it as well instead of doing a new line and typing C out again is you can have your string 4 times 4 is. And notice they put a space at the end of is here so that in the result you have a space between the word is and then the actual value of what result the variable will be. Does that make sense? No questions? Cool. You can also send multiple lines to the console by doing appending that end line or end L attribute, okay? And then you can see this is the result. And another way to do it so you don't have to type C out is just by using that insertion operator instead of putting a semicolon at the end of the end L. Cool? You could also do that all on one line if you wanted. We can also use cin, okay? So we did a bit of that today, and that's how you can read input from the console. So we covered that, how to store value into cin, and then you can actually make a calculation. You can do result value and then use that operation, that arithmetic operation, do value times value, and then you can say cout value times the word times, appending it with these insertion operators, value, and then appending the word equals, so we have 5, which is your value of the variable, times, which is that word there in the string. There's your value of the variable again, equals, and then here's the actual result that they appended into that. All right? How to read values from the console right here. So you can just do cin into the value 1 of whatever variable you have, and that's how you read from the console if someone's writing in the console. What other? How to chain extraction expressions. So you can read 2 values. All right. So you can read value 1 and value 2. So you can actually chain them. So if they enter 2 numbers, please enter 2 numbers, 4 and then 5. You can just do it like that and store it into 2 variables. Kind of cool. Let's see. The rest of them, what we talk about. Cover. Cool. So we're going to talk about the lab today. If you go onto Blackboard, did everyone follow that all right? I just wanted to bring some of those up just so you guys know that those are there in those slides there. If you go to Blackboard, the third option down under the video, under the quiz, is the week 2 lab that we're going to work on now. You can download the zip code, extract it. So you right click and then extract folder or extract zip, and then you can open it in CodeLite. Okay, so I can show you guys how to do that. If I just download it here. So here it is in its zip folder, and then I just have this button on Windows 10 to extract it. So I can hit extract all. Then you'll have this little option where you can decide where you want to extract it into your downloads folder or whatnot. I'm going to change the name week 2 labs example because I already have a week 2 lab project. So I'm going to extract it. And then it will open. I can close the old one. And we'll open here. And then in here, I have my C++. I have my .project. I have my .workspace, my compile flags. Okay. So I want basically this whole folder in CodeLite. What you can do, how did I do it? Add an existing project. Okay. So you right click your workspace and do add existing project. Now, when you download this and extract it, you're going to want to extract it in a location that doesn't have spaces. So here I am on downloads week 2 example. Okay. And I'm going to actually also change the name of this here. Should be fine. We'll try to see it. Okay. So if I right click my workspace and I do add an existing project, I browse to where I extracted the code. All right, so it's in my downloads, week 2 example, and then I just select the parent folder. Okay, I don't go in it, I just open. Okay, you can also, I think it's looking for a .project file, so you can do the .project file right there. Oops. And so I'm getting an error saying a similar name already exists. So I'm going to actually just delete this. Remove project. Okay. So now I will actually try to do it. Add an existing project. And then I click my .project file, and there it is. Okay, and then I have it right here. Okay, and then we can double click the main.cpp to close those. All right. So now I'm just going to shrink down my output view, and you can read the instructions for the week 2 lab right here. So we already created a program that asks a user for their favorite number between 1 and 100 and reads this number from the console. Now suppose that user enters the number 56. What we want to display to the console now is amazing, that's my favorite number too. No, really, 56 is my favorite number. Okay, so 2 sample runs of the program are found below. So enter your favorite number between 1 and 100. The user enters 56. Amazing, that's my favorite number too. No, really, 56 is my favorite number. Now say they change their mind and they enter 21. Okay, amazing, that's my favorite number too. No, really, 21 is my favorite number. All right, so right now there's just the template code. Your job is to build this program so that the output is as expected here. You can do it now. You can do it on your own time. I'm here to answer your questions if you have them. You can use the code that we already did today in our first program here. You can just copy this over, and then basically you want to print, okay, that favorite number variable to the screen and append it into this sentence, okay, which we just covered how to do in the PowerPoint. Any questions on how to do that? So it's found in the week 2 learning, the week 2 lab. Download the zip code, extract it, and open the main CPP file in CodeLite. You can also drag and drop the folder into your workspace. And then to submit it, you're basically going to just follow the instructions in that CPP file, build and run your program to make sure it's working correctly, and then zip that entire folder and upload it onto Blackboard so I can run it, okay? Any questions, let me know. It's due again Monday at midnight, so just before our next class. So if you have any questions, ask now. If not, then
do we have to just put main CPP file in our workspace, or we just can open full folder in another workspace?
So it's up to you how you want to
open file, open and open just folder. It will works, or no? We better put just main file in my current workspace. I just don't understand really the structures. Do I have to
how to import it?
Do I have to put all files to my workspace?
Yeah, so did you see how I added it?
Yes, why we cannot just do like file open and open folder?
Yeah, so I said you can do that. So like here on Blackboard, it says you can extract it and open it. You can also drag and drop the folder. So if you wanted to do that, here, if I remove this, project, yes. So you're saying you want to do file, open folder like that?
Yes.
Okay, and then we can try that. And then instead of doing this, we go up 1 and we open the week 2 lab folder and select that folder. Now you can see here, I'm in the Explorer tab, and there it is there. Now, it's not actually going to be in my workspace. You see, that's the issue with that.
Problem if it's if it's in your workspace, that's problem or no?
No, you want it in your workspace, because I won't be able to work on it here if it's not in my workspace. So the easiest way to do it is to right-click on your workspace, and then you can add an existing project, right? Because you unzipped it already. And then you just click the .project file that's in that zip and open it, and then it will come in its own folder right there.
I'm asked because
Everything already set.
when I'm open week 2 labs, it looks a little bit different. I have CodeLite folder, and after I just have some txt file, main cpp file, week 2 lab project, and week 2 lab workspace.
Yeah, so that's totally fine. So you're in your Windows Explorer, right? And this is what you see in here, all of these.
Yes, but yes. So what?
Okay. So what you want to do, you don't want to do anything in the Windows Explorer. You want to do it all from CodeLite because it doesn't know that this .project extension is a CodeLite extension until you like set the default.
So for CodeLite, it will be looks different, yeah?
Yeah, so from CodeLite, you're going to right click on your workspace and you're going to add an existing project. And that's where you're going to locate to the .project file.
Okay, thank you, Professor.
Yeah, no worries. Let me know if that works for you. You can share your screen and I can make sure you got it working on your machine.
I'm using another screen for WebEx, so I can share my screen.
Okay, no worries. Let me know if you get that working though. Cool. Any other questions there? So also, I would love it if you can put a comment in your code. So like you can erase these comments and then just put your first name and student number in there. Kendall, you said good for now. Awesome. That's great. Remember to watch that video on Blackboard, guys, the introduction to curriculum, just because that'll give you an idea of what we're going to cover. And if you have any questions and stuff that you want to cover there, then we can cover that. But awesome. I'm glad that you're happy with that then, guys. I'll stay on for a little bit. I'll probably end the recording if there's no more questions. I'll stay online for a little bit to answer some questions while you guys do the lab. And remember to do that quiz as well. All the assignments are due Monday. Yeah, everything will be, well, like this one will be due Monday. But if it's going to be like a major assignment, then I'll give you guys obviously more time to work on it. Cool. Great. This is just like a weekly lab. So I want to try to do, I'm going to do my best to give you guys a weekly recap quiz each week. So everything that we covered. So next week we'll do a recap quiz on errors and all the different types of errors and how errors are caused. And then you'll do that recap quiz at the beginning of next week so it refreshes your memory. And then you'll have a lab next week as well on whatever we cover. And it's just a basic kind of coding exercise to you know, reinforce what you learned today. I also, yeah. This one's just kind of a basic intro to using variables. And then we could do a little bit of a lab. And I can give you, you know, some examples of errors to fix the compiler and stuff so that you guys know what's going on. Cool. All right, so if there's no more questions, I'll just stop the recording here. Thanks for watching, guys. Everything you can find online. Yep.
Could you please show how we can upload our project? Because it's an instruction, please follow the instruction. And just I have to zip main file or I have to save all and zip full folder like week 2 labs.
Right. Okay, so to submit it, so basically I said to complete the lab, you're going to follow these instructions. And then once your code's working and you build and run it, and it's working the way you want it to do, then what you're going to do is you'll right-click your project inside of the workspace, and you're going to hit Open Containing Folder. So what that'll do is it'll open the it'll open that directory in your file explorer, and you'll see all of these. Okay, right? And what you're going to want to do is go up one directory so that it's that folder. You're going to right-click it. Oops, right-click it and send to a compressed zipped folder. And then you're going to call this week 2 lab complete or whatever you want to call it. And then that .zip is going to be what you upload. So when you go into your submission and you browse for local files, you're going to browse. It was in my downloads right here, week 2 example. You're going to submit that compressed zip folder right there and just upload it to Blackboard, and it will upload right here. And then you just hit submit in the bottom right. Cool? Did that answer your question? I can go through that again if that was too quick.
No, thank you. I understand. I'm just read that you have to zip main CPP file, and it's a little bit confusing because I have to zip full folder, not just one file. Yes.
Yeah, I can modify that so that it says the correct. Okay. So we'll type that instead. So basically, to submit, okay. Please follow the instructions in the main CPP file. Build and run your program to test it is working correctly. Okay. Then zip parent folder and upload it on Blackboard so I can run it. Does that make sense?
It's okay. Thank you. It's much clearer for me.
Oh, whoops. No worries. I will just put that there and submit it. So now it's a bit clearer with the instructions. Okay. Cool.
Asking because
Okay.
sometimes, in user class we have to submit. Sometimes we have to submit whole project. Sometimes like just one Java file. So it's very confusing what I have to submit.
Yeah. So because this is such a small program, really, I could get you guys just to like select all, Control A, and submit the text. But I want to get you guys used to submitting the entire project because later in the year, when it's a bigger project, I want you guys to know how to do that and get used to that process. So it'll be the same every time. Right? So technically you could just, copy or screenshot your code because it's just one file. But later in the year when we have like 3 or 4 files all in one project, it's just going to be easier if you can zip the whole project folder and upload the folder. So just getting you guys used to that system, then you'll just know how to do it every single time.
Okay, thank you. So we'll go to work with our lab.
Cool. All right. I'm going to pause the recording. I'm going to end the recording here. So thanks for watching if you're watching asynchronously. And we'll see you guys next week.